Greetings, fellow IMP travelers. I am the one and only Joaquin Sosa. Today I will be helping you how to figure out the thought-provoking POW, the great HANSUDINI. Of course, the first thing we need to know, as with all other POWs, is what is the situation and what do we need? Well, I recommend you get a full deck of cards, a pencil, some paper, and your brilliant mind. In the situation given to us, somebody puts down a card face up like 7, then puts face down on that 7 however many cards more in order to get to 12. We continue to do this until the deck is finished. The only exception to this is a face card, which you never put down as the face up card. If you get a face card, just put it back in the deck. If you have cards left over that do not fit into a full deck, put them aside. Now, flip over all the decks. Once we have done this, we can now figure out how Mr. Hansubada knew the total face value of the top cards. From here we can figure out that the only two quantitative values available to us are the number of piles, 1, 2, 3, 4, 5, 6, and the number of leftover cards. These two values will help us get to the total value of these top cards. Using these two variables, I collected data from attempts and formed them into an in and out table. Right off the bat, we can see that all data with the same number of piles and leftover cards add up to the same number. This happens quite a few times throughout our data, so we can say that it's safe to assume that any combination alike will equal to the same total face value. Next, we can look to the difference in face value the different number of piles may have in the total face value. For example, while the combination of 6 piles and 2 leftover cards equals 28, the combination of 7 piles and 2 leftover cards is 41. That's a 13 value increase for 1 extra pile. This is also true with 8 piles and 2 leftover cards. Its face value is 54, a 26 value difference from the 28, and a 13 value difference from 41. This seems to be constant in other instances, so let's continue. There is also a connection between how the number of leftover cards affects the overall face value. In our data, the total face value of 6 piles and 0 cards left over is 1 less than the total face value of 6 piles and 1 card left over. This is also a constant in our data, so we can say that each card left over is +1 to the total face value. So, as of now, we can say that each pile equals 13 points, and each leftover card is 1 point. However, there is also the question of what is the lowest possible total face value. So if we take the lowest face value cards, which are all aces, and make them into piles, we would still have 4 cards left over, and those 4 cards would be added to the 13 cards for each pile. This should equal correctly, right? Wrong! We would have 56 instead of the 4 we needed because of the aces. So how do we correct this? We could subtract the 52 from the 56 and we would be correct. Or, to make it even more simple, just subtract 4 from the number of piles we have, multiply that by 13, and add the number of leftover cards. Then we would have 4. Now we can simply turn that into an equation. Let's call piles P, leftover cards L, and the total face value V. As we said before, we simply subtract 4 from P, multiply that number by 13, and add L to that number to get V. Put this in accordance with order of operations and hooray! We have found an equation to help find out the total face value of the top cards!